Good morning, everyone. This is, oh shit, is it Thursday? Are we at the end of our first week of class? I think we are. Fall semester 2022. Let's do some Calculus 3. You guys hopefully watched the videos on 11.8. They are on converting between rectangular coordinate systems, cylindrical coordinate systems, and spherical coordinate systems. Hopefully cylindrical is familiar to you because you learned them in trig. X is r cosine theta, or hopefully learn them in trig. Y is r sine theta. The only difference is for cylindrical, we now have the z, but z is just z. And we know that r squared equals x squared plus y squared. So we can find r by taking the square root. And from the triangle, we have tangent theta equals y over x. So we can find theta by doing tangent inverse. The key thing when switching from cylindrical to spherical, since I already got the video up on how to do that, I don't want to redo that for you, but the big message is rho or r is the equivalent of rho sine phi. I constantly draw theta. So that changes our x when we come over to spherical. X becomes rho sine phi cosine theta. Y is rho sine phi sine theta. And we've got the sine theta, cosine theta, we've got the sine phis. We need the cosine phi. That comes up with z.
I think your share screens is lagging a good bit.
Okay, I'll pause. And then what other equations do we have? Z is also x squared plus y squared plus.
You mean it's rho squared?
I mean,
is equal to x squared.
Yeah.
Plus y squared plus c squared.
Yeah, I got distracted. Sorry.
You're
Rho
good.
squared's that. This is also r squared plus z squared.
Mm-hmm.
We can see that if we want to find phi, we already know how to find theta from tangent inverse of y over x. If we want phi, we notice z is, or cosine phi is z over rho. So this is going to be z over square root of x squared plus y squared plus z squared. So it's helpful to flashcard the shit out of those until you have them memorized. You literally only got to memorize them through this semester. When you get to your job, if you really need them, I'm sure you'll look them up, just because you're not going to be 100% confident because you're not going to use it that often, unless maybe you work for a, I don't know, beach ball company or something where you're producing a lot of spheres. Who knows? Who knows how often you'll need this spherical and cylindrical. We do a lot of things in life that are round because they roll well, so they do pop up. Let's take a look at converting some equations. Let's try switching cylindrical to rectangular. So what do we need here to switch from cylindrical to rectangular? The z is already good, so we can leave it alone. We need r squared to be switched. So we know r squared is x squared plus y squared. So we should have z equals x squared plus y squared. And that's a circle with radius r. Oh, we already know that. That's up there. So like the radius is the square root of z. In terms of sketching it, it's almost easier to look at this as a circle and go, okay, well, the height of the circle when I'm sketching it affects the radius. So if I have y here and x here and z here, I'm just going to focus on going around the z going upward. In fact, z can only be positive, right? Z is a squared term, and that's only positive. So at 0, x squared and y squared is 0, it's fine. As we go up in z, we should be getting circles that get bigger and bigger and bigger. So it should be making a cone, like a snow cone.
Yes, I too remember my calculus class being able to find the volume of an ice cream cone. It was great.
What is that? It's cone is 1/3 pi r squared h. I think that's volume.
I was never good at memorizing the volume of a lot of the irregular shapes like that.
I could be wrong. Let's see. Someone's chatting. Yep, Eli remembers it. 1/3 pi r squared h is the volume of that cone, but we're not doing volumes. We were just doing some sketches. Let's take a look at doing spherical. Let's try. Let me get a new piece of paper. Is there any questions on this one before I start switching?
I see no hands.
All good. All right. Let's move on. Let's kick it up a notch. We're going to start with let's make sure I'm on the screen. Rho minus 2 sine theta cosine theta. Is that what I want? I think I wrote it wrong. I don't think I want that. That's going to be a pain in the butt.
That's equals, right?
I think I want sine phi cosine theta. I was pulling it from the book. I don't think that one's going to be very easy. Let's see. Yeah, I want 2 sine phi. And we're going to say that equals 0.
Oh, I see how that works.
Okay, so we have some options. One of the options is going to be a pain in the butt. Is trying to figure out how we can say rho is square root of x squared plus y squared plus z squared. But switching this one can be a pain in the butt. We're missing a row. Like our equations, we have x equals rho sine phi cosine theta. But I don't have a row. So like maybe I could say this is like this part is x over rho. And I could do that because now I have x over square root of x squared plus y squared plus z squared. So one approach is saying this is x squared plus y squared plus z squared minus 2x over square root of x squared plus y squared plus z squared. And from there, we would get a common denominator by multiplying this one by itself. And we'd get x squared plus y squared plus z squared minus 2x over square root of x squared plus y squared plus z squared equals 0. Okay. Other than that, we already know the origin can't equal 0 in this case. We can't use the origin because it would be in the denominator. So we could multiply through by, and we're just going to end up with x squared plus y squared plus z squared minus 2x equals 0. I don't know if that's the easiest approach because there's a lot of work going on there, right? What if this was missing a row? Why don't we just multiply that son of a bitch, that whole equation, by row? equals 0 times rho is still 0. Well, this we have, this is x squared plus y squared plus z squared. And I got -2, and then that's just x. And I bypassed all the work of getting a common denominator or working with radicals. All of that shit skipped as long as we make the assumption that rho cannot equal 0. So what is this an equation of? Like this here is meaningless to me. That doesn't help. But here we could group by like variables. And if we complete the square, -2/1 squared is 1. We'll add 1 to both sides. This is what goes into parentheses. I've got x minus 1 squared plus y squared plus z squared equals 1.
I've got a question.
Okay.
Rho even 0 in the original equation because theta b can be any number.
He's asking if rho could be 0 in the previous equation. Is that right?
We found when we put it in that it's not gonna, it can't be because we're gonna have it in a denominator.
Well, like that, the original equation.
So like if you were not to know that that 0 would be on the that would turn out that way, how would you know that rho couldn't be 0 in this circumstance?
You have to, if you multiply by rho, you have to state it. I'm going to assume rho doesn't equal 0. And the reason why is I multiplied through by rho, and like multiplying through by 0 makes any statement true. Like 0 equals 0 every single time. So if you multiply through by a variable, no matter what variable is, you have to make the assumption that variable doesn't equal 0. This was an assumption back all the way in beginning algebra. Maybe not beginning algebra, intermediate algebra. But looking at the initial equation, I can't see that rho doesn't equal 0.
I hope that answers your question. Actually, I didn't even know that. You learn something new every day.
So what is this an equation of?
I'm hearing spheres.
It's a sphere of radius
1,
centered at
1, 0, 0.
1, 0, 0.
Centered at. There you go.
I heard that part. Okay, so pro tip: if you know the shape and it's a shape you can draw the shape first and then add the damn axes. That's my symbol for a sphere. I know that center is at 1, 0, 0. So I will put that like this. I will make that my x-axis. Throw in my z. Oh, maybe I should have gone, since I know it only goes 1. Go there. Y, z, x. Now it looks like a sphere at radius 1. I could put a little mark there to show it's going to there. Like that. Bam. That looks like a sphere at radius 1. Well, if that was a little bit more spherical. That looks kind of like a limp sphere. It's deflating.
But it took a lot less time than to trying to figure a way out of making a sphere that looks like it's actually at that spot.
Right. I think having the background coordinate system on there, the XYZ, the lines like kind of screw you up when you're drawing a picture.
Yeah.
Like if you can identify it's going to be a sphere, draw the sphere. if you can see from the picture like we had in the last one, where is it? The circular cone. It might be easier to draw the damn circular cone first, like that, then throw in your z-axis. Or if you want to make it look really good, you draw the circular cone in first. And you kind of make it so the Z comes out like that, so it's clear it's there, and then you do that to show that it's hiding inside the cone. That looks a hell of a lot better than this, and it looks better than that. But it helps knowing what that shape's going to be. Any questions? All right, let's let you guys work on some problems together. And if you guys have questions, I'm here and Brandon's here.
Oh, and before you get started, there was I don't know if you got the email or not, but my 12 to 2 hours on Mondays and Fridays has moved to Kern 712B. It's on Canvas, and my 8:30 to 9:30 on Fridays has not changed to from Yoga 13. Just letting you know.
That was always I know you had to. Oh, I had it. Yeah, but then it's like, you know, right? Huh?
There's no disguise at all.
Exactly.
Website wasn't working yesterday.
Hey, Mr. Jones,
Yeah.
that cone you made, was that supposed to be a cone or a paraboloid? I thought z equals x squared plus y squared. Is that not a paraboloid, or am I going crazy?
It's not, R squared is, it's making circles.
Mm-hmm.
If it was R squared and R was one of the variables, it would be a parabola. But this is going to be a circle, and so the circle is reducing at the same rate. It should be. I don't know. Let me think about that for a second.
Well, yeah, because if you say
If you put x in 0 and z equal y squared.
yeah, you get parabolas if you try to find
You're
it
right.
by relegating
That-
things to 0.
You are right. I didn't even do the damn shit I taught yesterday. Fail. Good catch. So that's going to make that a paraboloid also.
Yeah.
That's a little harder to sketch. I like my cone better. Why you got to ruin it with fact?
Okay, don't blame me. Blame one of your students. Can't
I
believe that
am.
you would catch it like that.
How dare you call out the teacher on his bullshit? No, thank you. Good catch. And this is why I'm not testing you on graphing this shit. Even something that looks easy, you can do something stupid on. You will have basic graphs like doing a sphere or a cylinder or some shit like that, but I think the idea is learning how to visualize stuff in 3D is a lot more effective here.
Yeah. I definitely know that I certainly haven't gotten all the 3D graphs memorized.
Now, the spherical and cylindrical will get pretty handy when we're
Oh, yeah.
doing integration and stuff like that, because we have
Oh,
equations
yeah.
for that. So keep that in mind. The spherical and cylindrical coordinates are useful. Why do a bunch of integration if you know the equation just ends up being a circle? You know the equation of the area of a circle. So you can trim a lot of shit down if you already know the answer. So keep in mind that this stuff is useful.
The more steps you have, the more likely it is to make a mistake.
What's the, is it always supposed to be? But that's the word, that's the right equation. I don't know, I was just going. I didn't get everything. I just want to know this is right.
That's the one here. So
Yeah.
that's the thing.
Had it shown. I did hold off and I didn't see it, so I was like, I was trying to do myself.
Yeah, but that's the equation. Yeah.
Okay.
And if you need to, there it has this recording, so you can see it later. You know, double check. So you have a question?
Eli or Jamie, if you have any questions while they're working, let me know.
Go to spherical. Okay, so the last one is B. Right. Am I right in U?
Oh, you mean in radians?
Yeah. Am I right in radians or just?
That should be fine. I don't typically radians are used a lot more than degrees anyway. Just make sure that your conversions are correct.
Probably should just
Yeah. Oh, yeah, something like that. I would definitely keep it that way and box that answer. For me, I like to keep my answers simple, and that I don't want to do extra steps to try to simplify them if I can help it. Yeah, I've been going by that logic since.
you're right.
For that one, I don't have that on me.
I searched online.
Convert to
This says Kindle.
I realize
the
calculator, and I can probably see what I can do. So you can make from spherical. So yeah. So spherical and
these are the cylindrical, on the mark, those nice, mark,
And you just can't find the. Oh, so can it be all of us? Where were you then? As long as you, the people that are true.
Well, I have a X equals R.
Is the, oh. Yeah, this is, I'm kind of using the polar for the rectangle to circle. So, if you. Yeah, I think, it sure is, it's good that you have to go from spherical to, cylindrical, but if you have to go from, cylindrical to rectangular to spherical, that will work there. Oh,
Wait, so it's giving us rotation?
It's always good to have a calculator in your pocket, right, Mr. Jones?
I didn't hear that. What?
It's always good to have a calculator in your pocket, am I right, Mr. Jones?
Oh, yeah. I try to do as much as I can in my head, even if it seems complicated, and then check it on the calculator. Helps keep
Oh,
that
yeah.
brain. But
Oh yeah, I try my best to do as much as I can in my head. It's good practice.
Someone's writing it, I don't know. I'm writing it as be like edit or. No, it's not, it's not. It's not. Yeah, I don't like.
So you know exactly when I can ask him. He could probably make edits because it was one of his lectures, right?
That's important, but I don't have to.
Yeah.
I guess it's just, if it's just X, Y. Inverse game. Is it inverse game?
Yeah.
And this is, but then if I can say inverse, then help. What's the answer on today?
I'll ask. We're for 11.2. I'm guessing 11.2 will be for Monday.
yes.
Yeah, so 11.2 will be for Monday. So make sure to watch it over the weekend, or if you don't want homework this weekend, watch it tomorrow. Tomorrow off. Watch it tonight. Just practice it.
11.2 is on vectors. If you guys have experience with vectors, it's going to be pretty easy.
very little.
And then 11.3 is on the dot product, and 11.4 is on the cross product.
Well, I already got this well, double. When you get into like. Yeah.
Yeah, it starts getting complicated, yeah.
We'll be using vector one.
Yeah, vectors are a huge part of this class. We are kind of in a, yeah, we are in kind of a class, so except that vector. Yeah, I've dealt with my share of vectors before this class, before my last semester. I'm not really class.
Something like. You also have R though.
Yeah.
Oh. Oh, no. Or R equals plus or minus. Because you're square rooting 64. Don't forget that. Or actually, wait. Never scratch that. Radiuses can't be negative, right? So it has to be. Yeah. I got this. It's 33. Oh, it's you remember your special rectangles. Is that what they're called? Yeah, don't worry, I don't remember the line. That's why I always keep it set. I always line to them.
What? They started.
I will make sure that it is the case. And Mr. Jones, I would assume that your tests are not open note, right?
Correct. That is a
So
safe
get your
assumption.
tests in.
You need to know this shit. At least fake it till you make it.
Even if you have to memorize it through repetitive work.
Flashcard, that's why I said do some flashcards in some of it. It really helps. If you watch the video and learn like how coming up, like doing spherical. This is X and Y and Z. Like if you memorize how it, or not memorize, but understand how the circle thing works, you'll be okay and not need to memorize if you know your trig. Like if we circle, go that far, and this is our radius, that makes an angle theta off the x-axis. And we're on a circle, so we want to go up to a point P or down to a point P or whatever. Let's say this is our point on the circle. We can make a triangle here. We got a triangle right here. So I'll draw that triangle like this. That's
it's like
R.
R.
This angle
that
right
would
here
be-
is phi, which
Mhm.
means opposite interior
Oh,
angles, that's phi. Because it's like Z is over here. So this is phi, which makes that phi.
Would you say the line that's going straight from the origin straight to the point, would you say that would be rho?
That's rho, yeah. That's rho. And since we're going, this is on right here, this is 0, 0. Or I'm sorry, this is X, Y, 0. When we're moving up to here, this makes this height Z. So
It's amazing how much geometry you can learn just from this first unit.
right? If we do cosine phi, adjacent over hypotenuse. So Z equals rho cosine phi. And we already know R. That's our x squared plus y squared from circles.
Oh, I was thinking, I was like, where am I remembering this from? That's right. This is the derivation of getting spherical coordinates and such.
Yeah, this is deriving spherical coordinates. So if you can sketch this real quick on an exam if you forget, if you're good enough with your trig and remember like how cosine and sine and shit like that works. I've had student do it. It impressed the shit out of me, but it's not I think it's easier to memorize the equations, but I think you gain more from it if you understand the derivation and can pull it up. It takes longer on a test. So in terms of test purposes, having the equation memorized is faster and you want that. But understanding where the equations come from the derivation pictorially, it means more.
Yeah.
It's not just
I know that like sometimes I'll like, oh, I forget how this works, but I know how this and this works, so I could probably convert it using this idea. You know, I definitely have done that more than once, converting a cylindrical to spherical to figure out what the equation was again. I know I remember doing that on an exam one time. Yes. Oh. Oh, I see what you're saying. I don't think you would say triangular that way. That way. Okay, so you have two as R. See, so now that you have the radius and you have an x or y value, you can find it a different way. So try to say what is the cylindrical version of x? Yes.
Try to figure out that special.
Special right triangles.
Okay.
Geometry thing.
I don't remember any of that. I know what you're talking about.
Don't worry, I didn't realize completely until calculus too.
So
What's pi over?
pi over 3,
That's 60 degrees.
Oh, that makes sense because there's the tangent. I'm doing something wrong. I'm doing a tangent.
Good job.
Like the last two.
You said.
I didn't get it. So I think the problem is I'm pretty low. I think. I'm gonna work on it. Right after lab today. It should be tangent. Tangent pi. I probably doing the inverse. Well, I don't know that the way I did it.
We're already
Get data by itself.
like
Just get data by itself.
Oh, yeah.
It's like we're kind of.
That's
No, you haven't.
Well, we're right now. It's one of the lakes.
Where did you get to that sort of thing? Is it
Isn't that what it is? Or is it this? Yeah. And then it goes.
Yeah.
Okay, that makes a lot more sense.
I'm like, how did you get the data in there?
Yeah, no, I thought that makes a lot more sense. I get that.
oh, you do
Then I get the answer. Yeah. And then it's pi over 3.
Yeah.
It's not like taking pi over 3, but then I got. Yeah.
Yeah, it's definitely good to have like at least like I know in calculus too, I have like one of my I did like internal notes on whiteboard, and one of my note pages is literally just a giant unit circle with like just like different lines that are talking to each other.
So I know the degrees on the unit circle, but when it comes to tangent, I usually get stumped. The sine over cosine. So basically,
It's the same.
sine.
So negative pi over 4 instead of the weight.
That makes
It's
sense.
it's backwards. That also
Over 2 over 1/2, which is not 1/2.
because it's still making a full circle. So going the negative direction is not going to change much. Okay. So it's the same way that negative 3 pi it's also just pi.
I thought about that one.
Yeah.
What you guys get for
That could be
R?
fine.
Number one. It should be square root of 54. So I thought that's true. Again, I don't know if I did anything wrong. They got that is great.
I just use fair.
For fun.
I wish I could do like stuff like that for fun.
I just had these.
Whenever I get like when someone gives me a problem, I get it. Like I need to.
I have to have like incentive. Like it's like it's just not something I've ever been able to do. I end up having to queue out the hockey thing. As much as I love that person, just sort of takes things apart.
Thinking about something.
I don't think it's enough.
I
Just do it. I mean, I can.
I couldn't say that I would do it.
I could.
I think I would end up doing it in a hobby because I took two business science class and actually with Mr. Jones and Mr. Brennan when Mr. Jones was still learning it. And it's myself doing it as a job because it's hundreds of lines of code and you're missing and it's one line. And you're making a simple code. It's so horrible. Oh, yeah. That is definitely one of the things.
I mean, I still live that.
It's something I enjoy. It's something I enjoy, but not something that I want to stress over.
60 degrees.
Because finding mistakes is so difficult, even if it's just small mistakes. Because sometimes it's not always so obvious. Oh, yeah. And that's why it would be a hobby thing, not a work thing, if you have deadlines. Or you're not the only one that forgets it's your kids or
So I know class is almost ending. If my mom passes away today or tomorrow, I might be able to do a weekend Starbucks, and I will let everyone know in an announcement. And yeah, I'll just, if it happens, I mean this weekend. I'm sure next weekend. I don't think I'm confident she's not going to make it till next weekend. I know it sounds like a little callous. I've accepted that she's going to pass away, so like I've dealt with that. So I'm just waiting for her suffering to end, kind of thing. And but I need to be there for my brother, who has not accepted it yet.
Had the time to accept. Just take the weekend off.
So I will let you guys know on Canvas as an announcement. I'll try to email everybody too, if I can, and do a Starbucks, what day and time I'll be there.
They're saying, I'm hearing some students saying that you could take the weekend off if you want.
I can, but if it becomes available, I don't mind doing it. I'll just let you guys know. I know it's the first week, so it's not so bad yet. So the first week's the easiest week to not do it, but just throwing it out there. I hope you guys have a good day, have a good week, and I'll see you guys on Monday. If I don't see
And don't forget, I have SI hours tomorrow at 8:30 and 12 to 2. Different buildings. Make sure you check Canvas. All right, I am going to sign out. I've got lab again.
I'll talk to you later.
Yeah.
See you guys online.